Hi everyone, and welcome to today's webinar focusing on a workflow that will allow you to take a 2D CAD model into Revit and frame it using MWF. I'm using a Revit file in DWG format and have decided to keep it nice and simple with this detached house model. We're going to take a look at how we can prepare our CAD model ready for Revit, how we can utilize the file within Revit, and then how we can frame the model using MWF. As you can see on my screen, I have a few views prepared for the 2D model. So we can see we've got a ground floor plan, first floor plan, we've got the associated elevations, and then we've got our roof plan at the top here. There are a couple of things I would advise or recommend that you do to prepare your file before importing it into Revit. Number one, I would clean up the file before exporting to Revit. By cleaning up the file, what I mean is we remove any excessive line work or any layers that we don't need to reference in Revit. So I have some dimensions showing here, and maybe I don't need to see those dimensions in Revit. What I can do is I can either delete or I can turn off the layers that I don't need to see. The next thing I'd recommend is that we separate views or any view references into one file per view reference. The reason for this is that we can import only the references that we need, and we can also place them exactly where we need to when we're referencing the position of doors, windows, and other elements. So we can place our ground floor plan on the ground floor plan level inside of Revit, and then we can align the reference to that level, and we can place our elements accordingly. One thing that I've personally found useful is that when I use blocks in my CAD file, I can then work with these a lot easier inside of the Revit application. I can explode my line work, my CAD line work in Revit, and I can still reference my blocks as one holistic element. If you explode a block, it will explode into smaller lines. But as you can see in this example here, we have two windows. A window on the right is a block reference, but the window on the left is an exploded or a element which is not made of a block, it's just made of line work. You can see in this case we have 35 elements which Revit would have to reference. But if you've got a block which is created as a block, you're only referencing that one element. So things like selection and manipulating the layers and other things is a lot easier when we can work with blocks in that case. Another thing I'd recommend is that we have a reference. So a point of reference in the model that we can use to align all of the elements in the way that we want. So as you can see here in our ground floor plan, in our first floor plan, these views, the first floor plan is meant to align with the ground floor plan, and it's important that we have a reference that we can select to make sure that the alignment is exactly as we want it. Another thing that I'd recommend is that we have a point in the model that we can use to check the scale. So in this case, we have our wall framing, or our wall structural layer, and I want this to be consistent with the layer that I'll create inside of Revit as well. And this is a nice easy reference that I can check. What I'm going to do is create a dimension in between this layer, and we can use this to check the scale at a later time just to make sure it's correct after we import the model into Revit. As I mentioned before, when we're separating our views, we can separate our views into their own DWG files, and this is a useful way of managing the view references. And as you can see, if I go into my folder where I've stored all of my views, you can see each of these views has been separated into their own separate file per view reference. So now if we jump into Revit, we can see how we can import the DWG files in the process and how we can do that. So now inside of Revit, we want to import our CAD file. When we import our file, we've got a couple of options. So if I go into the Insert tab, you'll see on the Link panel, we've got the option to link CAD, and on the Import panel, we've got the option to import CAD. So the difference between the two is if I was to link my CAD model, that CAD model would have to maintain a relationship with the original CAD file, so it could update based on any changes in the original CAD file. If I import the CAD file, then I'm importing the file at a set time, and I don't need to maintain the relationship with the original file. which means I've got a bit more flexibility when it comes to manipulating the CAD file. I can explode it, I can change the way things appear inside of the file as well, without it affecting the original file, or without having to link back or refer back to the original file. So what I'm going to do for today is I'm just going to use the import CAD option. And if I go to import CAD, then we can see within my folder, we have our files. So here within our folder, I want to bring in the ground floor plan. I'm in level 0 in my Revit model, and I want to bring in my level 0 floor plan. So when I've selected the DWG that I want to use, I can then choose how I want to bring it into Revit. So I've got the option of selecting the current view only, which means when I import the file and import my DWG file, my reference, it will only be placed in the current view only, and I'll only be able to view it in that view. If I leave this unchecked, it can also appear in other views, for example, 3D views, elevations, and other views, for example. For our layers, we can decide whether or not we want to keep the original layer colors. So we can preserve the layer colors, we can invert them. So if we're working on a black background in AutoCAD, for example, and we're using white lines, and now we're working on a white background, we can invert the color of the layers. So it's just visible in both options. And then we've got black and white, which will convert any lines into black and white lines rather than using colors. We've got layers, so we can choose which layers to bring in as well. So we've got bring in all layers, or we can choose to bring in only visible, and we can also specify which layers we want to bring in. As I've already done the cleanup in the CAD file, I don't need to do much more in this file to make sure that it's workable. So in this case, I can select visible because the layers that I want to use are already visible. Import units, we can select the units that we want to use, so we can override the units in the file, so we can use feet and inches, meters, any of these available. Otherwise, we can auto detect based on the units that we were using in the original DWG file. If there are any lines that are off axis, so they're not straight, we can auto correct those lines and straighten those as they're brought into Revit. When we're positioning our original DWG file in relation to our Revit project, we can choose how we want to position it. So we've got auto origin to origin, which is going to take that base point within our CAD file, and it's going to align to the base point within the Revit file. Auto center to center will detect the extents of the file, and it will find the center point, and it will place the model from its center in alignment with the base point in Revit. We've got manual origin, in which case we can define where we want to place it, and then we've got manual center, which is going to take the center of the CAD file, and we can detect it, and we can decide where to place the file based on its center point. For now, we're going to use the auto origin to origin option, and we can decide which level we want to place this file on as well. We're in level 0, and I want to place it on level 0. Orientate to view. This means it's going to match the orientation of our view, how it currently is placed. Okay, so how our view is currently orientated, it's going to orientate to match the view. So all that's left to do now is click open, and you can see it's going to take our origin point from our CAD file, and it's going to match it to the origin point in our Revit file. So just to prove that, if I go tap RH just to reveal any hidden elements, you can see this is our origin point in Revit, and this matches the origin point in our CAD file. You'll also notice when I select the CAD file that this file is pinned, and this is to prevent it from being moved accidentally, and we can also unpin this as well if we need to move the file for any reason. But as we've placed it based on the origin point, it's automatically dropped in the right position and it's pinned automatically. So now I've brought in the view for my ground floor. I want to bring in an elevation view as well, so I can set up my levels. So what I'm going to do is I'm going to go to my self elevation. So here in our self elevation, you can see that we have our existing Revit levels. And we also have our import symbol, which is our DWG file that we've imported into Revit. What I want to do now is bring in the self-elevation so we can see where our levels should be positioned in relation to the DWG file. So what I'm going to do is go into the Insert tab. I'm going to go to Import CAD. I'm going to load in my elevation south. I'm not going to change any of these properties here, but for our layers we do have the option to set all, visible, or specify. Again, I'm going to set it to visible and I'll click open. So once our file is brought in, you can see here that elevation is slightly higher than it should be in relation to our existing level 0 or our base point in the file. So what I can do here is I can move the import symbol. Usually they're pinned once they're imported, but I can unpin it, go to move, and then just make sure that our level 0 in our DWG file is aligned to our level 0 in Revit. You'll also notice that our level 1 is slightly higher than the level 1 inside of the DWG file. That's easy to fix. We can use the Align tool. So if I click on the level here, I can click on the Align tool, select a line within the DWG file, and align my level to it. We need an additional level for our roof, and we have a couple of options. I can either copy this existing level, or I can create a new level. The quickest method is to copy this level. So I'm just going to copy level 1 up to this roof level here. If you have line work in the DWG that you would like to reference, we also have another option. So if I click on this level line, if I use the level create tool, so I'll go to architecture, datum, click on level, then we have line where we can draw the level in position, or we can pick lines, which will pick a reference line from the DWG file. And I can then associate this level with this selected line here. You can see there that we have a level associated with that line. We can rename the level. I want this to be roof to match what we have in our DWG, and I'll just hit enter. As we've created a level with associated views, it's asking me if I would like to rename corresponding views, in which case I will say yes. And I'll show you exactly what we expect to see here. So we've got our roof level, and we have a roof plan generated for our roof level, or a plan view for our roof level. Okay, so as we've got our levels placed correctly, what we need to do now is make sure that our self-elevation is lined up or positioned correctly in relation to our ground floor plan. To see this more clearly, we can go into a 3D view where we can see that our elevation is slightly out of position for our exterior walls here. So there's an easy way that we can adjust this to make sure that they're in alignment. I'm going to go into my level 0 plan. In the architecture tab, I'm going to go to the work plane panel, and I want to create a reference plane. I'm going to use this reference plane to indicate where the exterior wall should be. And the great thing about a reference plane is this also shows in elevation views, such as our self-elevation in this case. So I'm going to click on my DWG, click move, and now I want to align this exterior wall to that reference plane. Now when we check in 3D, you can see that our walls are aligned nicely, and our doors and other elements are nicely positioned. It's best practice to also check the scale and make sure that the scale of the imported element is correct. And what I can do to check the scale of this model is I can go to the reference point that we've used previously and just take a measurement just to make sure that the dimensions are consistent. So if I go to the Annotate tab, I can create an aligned dimension, and I can select the same references that I chose in my DWG file previously. There's a 100mm structural layer here, and if we go back to our DWG file, you'll see that we have 100mm structural layer thickness here as well. So now we've made sure that our DWGs and our CAD files are nicely aligned, are positioned correctly, our levels are placed as they should be. We need to place our geometry. So now we want to place our walls. We may want to place some floors and other elements as well. So what I'm going to do here is I'm going to create a wall type to match what we have in our model. So the first thing I want to do is I want to measure this wall to make sure we're getting the same values, or using the same values for our wall build-up. So you can see here, if I take the measurements for the structural layer and the sheathing layers, I'm just going to change the scale. We've got a 100mm structural layer and we've got 13mm sheathing boards. I just want to double check that these sheathing boards are indeed 13mm, as I believe this might not actually be the case. So let me double check on this one. Okay, so I'm going to go into my units and I want to change the precision just to make sure it's giving me the right reading. Okay, so you can see here that we've got 100mm structural layer and 12.5mm sheathing boards. So I want to create a new wall type, so I'm going to go to architecture, wall, and here we have a list of wall types. So I want to use the wall partition with a 75mm stud. I'm going to use this as a benchmark because it closely matches what I have here. So we've got two sheathing layers and we've got one structural layer or one stud layer. So I'm going to go to edit type and I want to duplicate this type to create my very own. So I'm going to call this one interior because this is for an interior wall. And I'm going to say 100mm stud with 12.5mm sheathing. And I'll click OK. And now I want to make sure that the structural layer matches what I have in the description. So if I go to structure, click edit, we can see the wall composition. I have two finished layers, one on the exterior side, 12.5mm, and one on the interior side, again, which is 12.5mm, which is what we want. For the structural layer, I want to make sure that this is set to 100mm to match the structural layer thickness that we have in our wall. For Revit, it's important that we distinguish which layers are which, and for MWF, it's also important that we have our wall set up correctly as well. I'll come back to the MWF portion shortly, but for now, I'll just make sure the wall is correct. So now we have our own wall type, and if I wanted to generate my walls now, I can simply click to place those around the model. So it's very easy to place our walls. We can do that fairly quickly by clicking between point A and point B. So for exterior walls, I have some walls which I've already generated. So if I go into the wall tool, you'll see that we have exterior brick on wood stud for our ground floor. And just like before, we can choose how we want to place our wall. So I can take this center line and I can position my wall in relation to the center line, as you can see. When we're drawing our walls in Revit, it's important that we draw them in a clockwise manner in order for them to be orientated correctly, but it's very easy to adjust that if we do accidentally draw them in the wrong orientation. So as well as using the drawing tools, we also have a range of pick tools that we can use as well. going to create this wall here. And I'll just use the edit tools just to finish this one off. As you can see, we've got our walls which are placed, and we can now remove this dimension. Okay. We have another wall type here, and as you can see, it's slightly thicker than the wall that we have positioned. So what I want to do is generate another wall type to match this scenario. So again, I can select the wall that I've got, go to edit type, and make the adjustments there. So once our walls have all been drawn and placed correctly, then we may need to place our floors and roofs. With floors and roofs, we can create those in a similar way to how we created our wall. So if I go to the floor option, you'll see we have our floor type, and in the type properties, we can duplicate, we can rename an existing one. But here we've got the floor composition, in which case we can specify the layer thicknesses. I'm going to place a very simple floor. I just want to create a ground bearing floor in this case. And I'm going to, we have a couple of methods on how we can do this. Again, we can place using lines. We can use rectangles and other shapes. We have pick lines, where we can pick line work in the DWG file if it's available. Or if we have existing walls in place, which we do now, we can use the pick walls tool to do that. So you can pick walls one by one, or if I hit tab on the keyboard, it's going to pick all of the walls which are joined, or a continuous loop. So I can simply select all the walls at once, and we can choose which part of the wall we want to extend to, the middle of the wall or the face of the wall. So I'm just going to make this the middle of the wall in this case, and hit the tick there. So now in 3D, this is currently what we have based on what we've just placed in our model. So it's starting to come together, not quite there yet, but it's starting to come together. So now I need to make sure that the walls are referenced up to the first floor. So I can select all of my walls here. In my filter, if I want to make sure only walls are selected, I can select walls, and then all of my walls are selected here. In my wall properties, we've got the walls constrained to the level 0, so this level here, and we want them to stop at the first floor. So top constraint, I want this to be up to level 1. You can see there, it will stop at level 1 in this case. Now when we look at our plan or our model, you can see there's my walls and how they're positioned in the model. Okay, so now I need to bring in my level 1 floor plan. So I'm going to go to level 1. I'm going to go to insert, and I want to import CAD. Here in my folder, I've got my level 1 floor plan, and I just want to bring in my DWG as is. Position wise, you can see it's slightly out of alignment, no problem at all. What I can do is reposition it, and in order to do that, what I want to do first is turn off any lines that we don't need. So in this case, when you bring in an imported model, you can query the model, which will allow you to see any line work within that model. Here I have a line which is not part of the exterior walls, but you can see it's on the dimension layer. What I want to do is I want to hide these in view. You can see there, they're no longer visible. We can hit escape, and now we can see just the geometry for our walls, which is what we want in this case. It's going to click move, and I want to move my imported view so it aligns with the exterior walls on the view just beneath. So just want to choose the right reference, and we can use that wall as the top corner as a reference. Again, in our 3D view, we just want to make sure that everything is aligned as we want it to be. You can see here, based on our line work and our walls, that this is all aligned nicely. So again, in our first floor, we can start to build up the wall composition. And if I go to architecture, wall, We want to make sure that we're positioning our walls on the first floor and that they're ending at the roof level. And then from there, we can do what we did before by just drawing in our walls. Just want to select the right wall type, and then we can start to draw in our walls. So this is my wall on the first floor, which is slightly different to the wall on the ground floor. Okay. So again, we just want to place the interior walls. Now once our walls are all placed, we can check the 3D model again, just to make sure that everything is constrained to where it should be. So I can tab select these exterior walls, just make sure that those are finishing up, at the roof level as we want them to. Okay. So it's slowly coming together, as you can see. So now I'm going to place the floor on level 1. So I'm going to go into the floor tool, and I'm going to select the timber floor. And if I go to edit type, I can duplicate it. So I'm going to keep the name in very similar. So you can have a 20 mil chipboard, and we can have 200 mil joist. I'll click OK, and there we have a new type. I want to modify the structural layer, or the chipboard layer and the structural layer, just to match the name, to make sure it corresponds and is consistent. I'll click OK, and there we have our floor type. So again, I want to select the floor boundary using my walls. So I'm going to use pick walls, hit tab to pick up on these areas, and then I'm going to make sure that the walls, any walls that are going up to the floor from beneath, they're going to stop at the bottom of the floor. So I can attach them, or I don't have to attach them, but in this case I'll just say attach, just so they're not going through the floor. Okay, so now in our 3D view, you can see that is our new floor that we've just generated, and the model is slowly coming together. So all that's left to do now for the main structural elements is to place our roofs. So in that case, I need to bring in my roof plan, and I just want to bring in my roof plan view. So we would have a roof reference here, but we also want to see a roof reference in plan view so we know exactly where our roof should be positioned. So I'm going to go to Insert, Import CAD, and I'm going to choose the roof plan model. I'll click OK, and you can see it's positioned in our model. I'm going to unpin it just so I can align it correctly. And again, I want to select a reference that is consistent with what we've used previously. I'm going to click Move, and I want to reposition our model so the walls are located correctly. Okay. So in our roof plan, this will be the easiest view for us to see our roof level. And let me just make sure that this import symbol is on the right level, so I can move it to the roof level. You can see there, this is where our roof plan is, and this is where we can generate our roof. So if I go into my roof floor plan, this is our roof, and in the architecture tab, I can now generate a new roof by footprint. So here we want to define the boundary lines for our roof. So the easiest way to do that is to click on the lines in the model. So I'm going to select these lines, but just like before, we can also use the tab key, but we may pick up on some things which we don't need. So I'm just going to select the boundaries for the first roof on the roof level. And once I've selected the boundary, I need to define the areas which are going to create a slope in the roof. So I just want to select the areas that I don't want to define a slope for. So in that case, this one will not define a slope. This one will not define a slope. We'll have a slope defined here, and we don't want to have a defining slope there. There are some portions of this roof where we want the roof to change direction. So what I need to do is split this roof into smaller portions in those areas, just to make sure that this can change direction accordingly. We can see there that we have another change. So for this one, we can define slope. And for all of these slope defining lines, I want to make sure that the angle is set to 30 degrees as it is. And for any areas that we want to manually set the slope, I can create a slope arrow to determine where the slope should start and where it should stop. We have some options to control how the slope is defined, and I want to use a slope of 30 degrees just to make it consistent with with the other values in the model. So I'm going to make this one non-slope defining. Sorry, this line. And I want to use some slope arrows in this case. So I'm going to split lines here. And now I can actually move this to that midpoint there. Okay, and then I need to place some slope arrows just to define the slope of this roof in this area. And again, we want it to be consistent using a slope value that matches what we have defined previously. So I'm going to hit the green tick, and then we can have a look at what we've created so far. So if I go into my 3D view, then you'll see this is our roof. It's close, but not quite what we want, because in our CAD view here, we have a straight roof left to right in that case. So I need to go back to Revit, where I can make sure that we don't define a slope on this edge. I'll just uncheck this one. Okay. So I'm going to remove this one, and I just need to use a slope arrow there instead. There you go. I want this to be 30 degrees. Okay. And there we have our roof. I'm going to change the roof type just to one that's not as thick. So you can see here that we've got our roof tile. And this is our roof, as you can see. There's another roof we need to generate on the first floor. So again, I'm going to go into the plan view, or into the top view here. I could go into my roof, my level 1 plan view, but I wouldn't be able to see the reference here, as this is a roof plan view and the roof plan is in 2D. So I'm just going to generate it here in the 3D view. I'm going to click roof. I can set the level to level 1. And then again, I can pick the boundary elements. So I can pick lines. To define the boundary of the roof. We may want to double check that the reference that we're selecting is the reference that we want. So I want to make sure that this is aligned to the wall. the exterior wall. And again, I want to make sure it's aligned to this exterior wall here as well. Okay, we can use the align tool to do that. We can use the trim tool to clean up our line work. And then once finished, we can then specify the areas which will define a slope. So in this case, we don't want a slope in this area. So we say do not define slope, and we don't want a slope in this area here either. So we want to create a slope in the north and south directions here in this case. And I'm going to get rid of the slope defining lines as well. So what I need to do now is for any walls where I want to change or adjust the profile to match the profile of the roof, we have two options. We can use the edit profile tool, in which case we can then pick the profile of the roof by using pick lines, and we can pick the roof profile and then trim our line work to match the profile of the roof. Or the other option is that we can select our walls. So I'm going to hit tab to select all of my walls at the first floor, and we have the attach top and base option, in which case we can select the roof and attach our walls to the roof just like that. So all that's left to do now is to insert windows and doors, and the easiest way to place windows and doors is in our plan views. So here I've got some doors, some interior doors, an exterior door, and we've got some windows as well. So in architecture, we can click on the door command, and we have some door sizes which are available. We can take a measurement just to pick up on the opening size. We want to make sure we're getting the correct measurement there. So we've got the 910 opening, in which case I'll use a 910 door. So we want to match the door swing as shown in the plan view. Okay. We can come back and fix the alignment of the doors shortly. We can use spacebar to flip the orientation of the door, and we can place these as and where you need them. For our windows, we can go to the window command, and here we have a few windows that we can choose from. We want to make sure that the windows are the correct size, and we can check this by referring back to our CAD plan where necessary. So in this case, we've got a 910 opening. We appear to have another one here. Got a slightly wider opening there. $18.10. Again, we can flip the orientation using the space bar where necessary for easy placement. Okay. And we want to make sure we add the windows and doors on the first floor level as well. Now all of our windows and doors are placed. We want to make sure that they're placed in the correct locations. I need to also place the garage doors here, so I need to go to door, and I've just loaded in the garage door here. So we've got garage doors, where we have a couple of options for doors. So now we've got all the roofs positioned, walls positioned. We've got majority of the windows and doors positioned as well. All I need to do is check the height of some of these openings just to make sure they're consistent with what we have in our DWG. So what I can see here is that we've got these openings, which appear to be too tall. So we have another window type that we can use. We've got an 18, 9, 10, and again we've got another 18, 10 model. So for these windows, I need to make sure I'm taking a dimension in my self elevation for the sill height, so the correct sill height here. Okay, so the sill height in that case is 1500. So select these two windows. And we can do things like that. Okay, and I believe this one will be the same. So now we've made the adjustments that we need to make. You can see this is how we can take our AutoCAD model into Revit and start to build it up. I don't need to see the references for the DWG anymore. So what we can do is go to our visibility graphics. So I can type VV on the keyboard, or you can also access this via the View tab. So if we go into View, you can go into visibility graphics, where we can turn off any imported categories. So we can uncheck show imported categories in this view, and that will just remove them. And then we can focus more on the Revit model. So now we've finished with the Revit model creation, we can now make a start on the MWF framing. So the first thing we need to do when working with MWF in a new project is we need to load data. So load data allows us to bring in any MWF components and also any markers, rule sets, and MWF data that you may need for a more efficient framing. So I'm going to click OK and load in both framing components and MWF components. And once complete, I'll have some data that I can use related to MWF. So I'm going to go into the wall module, and I'm going to start by framing my walls. The easiest way to frame our walls is to go to the associated plan view. So I'm going to go to level 0 first of all and make a start on framing my level 0 elements. So the first thing we need to do when we go to frame any of our panels is we need to load in the families that we need, the right size families for our walls. So what I'm going to do is go to the Insert tab, Load Family, which will take me to my MWF specific families. I want to make sure I'm going to the wall framing families. So you can see in this folder here, we have walls, framing components, metric, and we have MWF standard. Here within this folder, we have a range of different families that we can use to help with framing, but we want to focus on the dimension lumber families, so the metric dimension lumber. From there, we've got a range of options available, but I want to choose the 38 by 140 family and the 38 by 114. I'll click OK, and those will be loaded in to my project. Just to check, I'll type BM for beam, and we'll just check that these dimension lumber families are available. So we've got 38 by 114, 38 by 140. So now I'm going to click on one of my walls. So I'm going to choose this 140mm layer here, for example, this wall here. And I'm going to go to MWF, hit create. I can specify a template, so go to template, choose the wood default template, set as active, hit close and create. So I'm going to use the default settings in order to create my panels, just to demonstrate how quickly we can frame using MWF. So today we have the 38 by 140 families in this panel, which is absolutely fine. I'll click OK, and here you can see we have our panel. We have a range of tools that can help with placement of members. So maybe in this particular section here, I want to add a join marker. So I can select the walls, click on place join. You can see it recognizes that we have 3 walls in this intersection. As we're working with wood members in this case, we can specify how we would want these walls to join. So I'm going to choose the long main B just for this join. You'll see that it positions the markers accordingly. Again, for this wall, I'm going to go to MWF and I can simply hit create. There is a quicker way that I can use with these particular wall types, and what I can do is create a template. So for this size that we're using, I can create a new template, use the wood default, set as active, close and create. And now if I need to make my very own settings or my very own template, I can go into the miscellaneous tab to change the stud spacing. I can change the family members in the general tab. So for example, if I wanted to use the 38 by 114 families, then I can specify those families in here. Click OK. And it will apply those settings to this template. In this case, we don't have a structural layer of 114, 114 mil. We've got a structural layer of 100 mil. So what we can do is I can select one of these members, go to edit type, duplicate, and I can generate a new member type. For the dimensions, we've got 38 by 114. I'm just going to make this 38 by 100 and click OK. So as this new family is available, I can start to create my panels using this size member. So I can go into the panel properties, change the member size to the 38 by 100, and also in the miscellaneous tab around any openings, we want to make sure that we're using the correct size family here as well. And then I can click OK. And the panel will adjust accordingly. So now these properties that I've applied to this panel, I can save them as a template. So I'll go back into MWF properties, template, and I can say manage folder, new folder, webinar. And within the webinar folder, I can then save my new template. So wood 100 millimeter. So wood 38 by 100. Simple as that. So if I go back into my default folder, I can simply move it from this location into webinar and click OK, where we'll find a webinar template. I want to make this the active template, so I'm going to set as active, hit close and OK. And now I can apply this template for my 100 mil layers where I need 100 mil thickness for the structural layers. In this particular wall, I want this to be 140 mil. So I can go to template, select the wood default, set as active, close and OK. And as you can see, it's just resized for that. So to apply these panels quickly across the project, we have something called a template map. Within the template map, I can create my very own template map. So I'm just going to call this one Webinar TM. And I'm going to add a couple of rows of data. So for the wall type that I have selected, the 100mm stud, I want to select that Revit wall type, and I want to create a second row for my 140mm stud as well. And I need to create a final type for my exterior wall, which is going to be, or my exterior walls, sorry, for my exterior brick on wood stud, which will both be available here. So you can see wall type, MWF template, and the structural layer thickness. So for the 100mm interior wall, I want to use my template, which is for a 100mm thickness. For my interior 140, I need a 140mm of thickness, so we can use the default wood template for this one, and the same for our exterior wall or exterior walls. So once we've mapped the template to our Revit wall types, this will speed up the process of applying our panels to our walls. So all I need to do now is select the walls which aren't panelized, and I can simply go to MWF and say quick create. For the remaining exterior walls, I want to do the same thing. Select the walls and again quick create. So this is really speeding up the process of applying all of our wall settings, all of our panel settings to each of these walls. As you can see, our exterior walls are all labeled. Our members are placed according to the settings and according to our join marker as well in this case. So I want to go into my 3D view where we can take a look at our walls just to see how the framing is placed within the walls. Okay. On the ground floor, you can see around our window openings, our door openings, our framing is placed as expected. And then for the first floor, we want to do the same thing. So what I'm going to do is select all the walls on the first floor, filter, only my walls, click OK, and simply hit quick create. Okay, so our first floor is now framed as well. And if you want, we can take a look at the framing on the first floor. You can see that all of our walls are panelized internally and externally. So all that's left to do now, so I'll just bring back the roof. I'm going to select my roof, or the two roofs here, and we can frame these using the rafter module. So I can go to MWF. In the truss module, we have rafters, and I can simply hit create. And this is just to demonstrate how quickly I can frame this model in the wood settings. So we can choose our rafter system. We can opt to frame it now, and I can simply hit create. I can select a layer within my roof to align to, and I want it to be my structural layer in this case. So I'll click OK. And it's going to place my rafter members in alignment with that structural layer. We can also integrate a bird's mouth cut if we need one. In this case, I'm not going to do that. And it's going to panelize each face of our roof according to the settings. Okay, so all that's left to do now is regenerate. And now you'll see that the frame members will be placed accordingly. Okay, so for our roof, again, I'm going to turn off or change the transparency level so we can see through the roof and see the members and how they're positioned. And finally, I just want to frame the floor. So I'm going to go to my level 1 floor plan. I want to select the floor in this view. The easiest way to do that is to select the face. Okay, so I should have the floor selected. Okay, make sure I've got the filter. Select floors. And what I want to do is go to, make sure that we create an opening in the floor where we need one. So I can say edit boundary. I could also use a shaft opening. So if I go to my opening panel, I've got the shaft option where I can either draw some lines or create a rectangular opening in the floor. And there we have our opening within the floor. So again, I'm going to make sure I select the floor and go to MWF. Into the floor module this time, where I can simply hit create to generate a wood framed floor. Just like with our walls, we can load in the families that we need, but in this case, I just want to simply create a framed floor. So I can regenerate the panel. And now in our 3D view, you can see we've got our floor. We can just change the transparency level there as well. So what I'm going to do now is change the visibility graphics for our walls, for our floors, for our roofs, so we can focus more specifically on the framing elements in the view. And that's just to demonstrate how we can go from AutoCAD to Revit to MWF and have our model fully framed in no time. Okay. Hope you enjoyed the webinar. That's all from me.